Alika the dreamer. Josephino. Why the offer?
I want that too.
Yes.
Okay. You're all welcome to the Physics Academic, and quite some days now we've been doing some posting and advertisement about today's class, and so far so good. We are going to start class, and if this is your first time of joining us or of hearing of a specific physics academic, it's another academic that talk much on physics and maths. We bring students, we coach students, we mentor students, and you can search us on Facebook at Explicit Physics Academic. We are on Instagram, Explicit Physics Academic. We are also on WhatsApp, of course, +234 811 8968. So we're about to start, and we're going to be talking about differentiation. Okay, we're talking about differentiation. What is differentiation? I believe if you are watching this video as a student or as a newbie in science or in math, you must have been asking yourself, what is differentiation? Like, where does it come from? Why do we do differentiation? Why? Now, calculus is a fundamental math. If you're a physics student and you don't know calculus, then you don't know what you are doing, because we need calculus to solve our problems. It's helping us and intercept us a lot. So it's very, very pertinent that we know what's calculus. Now back to differentiation. Differentiation is is one of the concepts or the building blocks of calculus. Of course, we have limits, we have differentiation, we have integration, and then the advanced part, the Laplace transform, and all of those all falls under calculus. So differentiation is just the process of you finding the derivative. So I'm going to be talking about derivative, and we're going to be talking about the first principle solutions, and we'll be solving some examples, and from there we'll move on. And I believe at the end of the class, you must have known trick of solving differentiation. If you've not known them, well, I believe in this class you're going to know those little trick in solving some differentiation very fast, really fast. Like if you are given in 2 seconds, you're given a problem, I want to solve it. How do you go about it? You're going to see it at the end of this class. Okay, back to our topic, differentiation. Before we go into differentiation now, I'm going to draw a graph, something you've noted or you've known for some time. Okay, these are our x-axis and these are our y-axis. Let's say we are given variables. What's a variable? A variable is a quantity that changes over time. It changes, it varies. Okay, so we are given this. Okay, these are our y, these are our x, and this is a change in x, and this is change in y. Now, in your basic knowledge, you've known that variable, of course, is so differentiation is slope is m is equal to change in y all over change in x. You've already known this concept in math, that this is change in y all over change in x. It's all familiar, everybody knows that, and of course they have been applying that severally, and they have to find a slope and a given variable. Let's say this is current, this is time. You go to apply some of this concept to find the slope and all of that. All of course we know that, but what are we going to do now? We want to find differentiation. Before we find differentiation, I would like to explain some basic things here so that you won't get it all confused. Of course, you know this symbol, and you know this symbol. Yeah, okay, let me use the black pen, so the black marker, so it will be more clearer. Okay, you know this symbol, and you know this symbol. These increments, this differentiation, and this infinitesimal increment, del, and so on and so forth. Okay, but that's not what we're talking about now. Now, when you want to find a slope in a graph, we all know that we use this symbol, right? Why do we use it? Increment. Del, Here we're talking about that it is known. Let's say here is 3, here is 5. Okay, yeah, 5. Here is 2, here is 3. Let's make the analysis together. Here is 2, here is 5, here is 2, here is 3. So we are going to have slope m as being equal to change in y all over change in x, which is equal to here is y1, here is y2, so it will be 5 minus 2 all over 3 is x2 is x1, 3 minus 2, and that will be we are going to have 3 all over 1, and our slope is equal to what? 3. It's very clear, right? Yeah, it is. Now, we've gotten our slope to be 3. But what's the most interesting part of this thing we are doing here now? Or why did I come up with this? Now, because differentiation all comes from variables. What is changing? What is changing? That's why I say that if you are doing physics and you don't know differentiation, then you don't know what you are doing. Because in physics, variables changing. So anytime something changes, we ought to find the difference in those changes. That difference is where the differentiation is coming into. Now, in integration aspect of which I believe we'll talk about it in subsequent days or weeks to come. Now, in integration aspect of it now, if we want to talk about integration, there are so much, and I want to find the integral. Let's say you're having grain of rice scattered in this particular region, and I don't know how to find the sum of it. So that's why we have the integral sign here from this point. Let's say this point A, this point B. You find the integral from point A to point B, and you start working on it, and at the end of the day, you get the integral, the sum. Okay, that's by the way. So we're still talking about the slope. We have our slope as 3. Now, why do we not use this symbol? Now, this symbol is changed. Now, when we use this symbol, we are talking about this symbol. Wherever you see us using this symbol, now we are talking about finite change. Now, finite change is it's obvious. What is really obvious? Now, you want to find the change here. Why? It's quite very clear. It's quite very clear. You can find the derivative. Now, this is the derivative. Okay, let's take them to so that you appreciate what we are doing. Okay. The process of finding derivative of a function is called differentiation. That's in calculus. That's the process of you finding the derivative. So what we are doing here, and now derivative is the rate of change of a function with respect to another function. Derivative itself. Now let's just go back to the drawing board. Now differentiation is the rate, is the process of finding derivative. That's this. Let me write it very clear. Derivative. That's differentiation. Is the process of finding derivative. Okay, now what is derivative? Derivative is just the change of a variable with respect to another variable. I'll give you some instances. You know velocity. What's velocity? Is distance over time. That's the rate of change of distance with respect to time. So I can find the derivative of speed by differentiating time, so distance over time. Why? Let's say they can't move from here to here. You can see that the speed is equal to the change in distance d all over change in time, which means that the slope of distance time graph gives us the speed. So that's how we find the derivative. Now the derivative is very clear. So why do we do differentiation? Now differentiation coming when we are dealing with a little change, infinitesimal change. At that point you cannot use derivative to find it. You have to use differentiation. Infinitesimal change. Let's say for instance, okay, please, if you are writing this, can note this very well. Let's say we have another graph here. Yes, sorry for that. We have another graph here. I'm still making instances before I start entering into the core problem. And this graph is curved. This is a point, this is point. And now you want to find the change of this variable. Let's say this is V, this is time, this is velocity time graph, and the graph is a bit curved. let's say the movement of the vehicle didn't move straight, it moves curved, like really curved. So what do we do? Like, how do we actually do this? Like, how do we do it? Now, in this point, if you want to find the change is infinitesimal. It's so little. So at that point, you don't find the derivative, you find the differentiation of it. And that is where this symbol comes in. Most textbooks or most texts have some texts use this, while some texts use infinitesimal as this. This and this differentiation, this infinitesimal, that's little change. That's little change. So whenever you find these symbols in any textbook you are reading or in any video you are going to be watching to advance your knowledge on differentiation, you should note that this little symbol tells us of something else, and this one tells us of another thing. So if I see this symbol now, as a physics student or as a mathematics student, you should know that we are dealing with infinitesimal change, a little change, a little displacement. I'm keeping two markers here. Okay, this is the blue marker, this is the green marker, and I want to understand what happens here. Let's say, okay, the marker changes a bit. I cannot use derivative, this del symbol, to find this change. No, I cannot use that. But what can I use to find this little change? Is where we use the infinitesimal change, this del. That's what we use to find it. Hope it's not making sense now. So this is what we actually use in finding the change. Okay, I'm going to clean this and get it all real clear again. Please, if you are watching this video, you can as well share the video across. Share it to other people, share it to other platforms so that they can join the class. Today I've decided to do this good. Okay. All right, let's do this. Okay, we have this. Okay. Just give me a sec. All right. We have this, and okay. Please, I want to try and make it more clearer to you. This is X. This, so that if you are noting this thing, possibly you can save up the video for yourself, and later you can watch it so that it won't make sense to you later when you sit on it. Okay. This is point P. This point Q. Okay. We have this. And we have this as well. This is the Y. This Y2, Y1, X1, and X2. Now, okay. Now, the gradient of this graph up here, I don't know whether it's too clear for you over there. The gradient of this graph tells us of the slope. So now if I want to find the change, what do? The gradient, of course, will be M is being equal to infinitesimal change of Y, the X, which is equal to change in Y, change in X. Now this is the change we are going to use here. Yeah, it's quite clear. There is no little trick of you coming in or doing any other thing. So this is a change we use in this aspect. Why do we use it now? Our gradient will be equal to y2 minus y1 all over x2 minus x1. And when you now put your values here, you get the gradient being n. That's very, this is very clear from this particular graph. For the way it is very clear for someone to find the gradient of this graph. It's very, very clear. It's very, very clear. But now, what now happens when we start having curves? This is for a straight line graph. I'm still explaining differentiation before we start solving the first principle, the second principle, and all of that. So let's just deal with this. Let's just deal with that. Okay, so what now happens when we start dealing with all of that on? Okay, so this is for the straight line graph. You've seen the symbol I've been explaining to you earlier. What we are using here, the dot symbol here, change, meaning change in y and change in x. That's what we use in finding, because this one is finite. Like the values here are clear and you have, at least you can see them. You have where they are stopping. So we use that. But what now happens when we're having a curve graph? Let me just clean the video so that I can explain the other one. Okay, so we are having this. All right, this is the curve. This is P, this is Q. All right, this is X1. Okay, now this is a aspect of a curve graph. Please don't get lost there. We've talked about in a straight line graph what happened and the symbol used there. Now I want to finish this so that I can now put everything all together and it start making sense to you, so that when you start seeing practical problem, you should know what am I to use. What is needed in this aspect? What do I use in solving, in dealing with this, in doing that? So you know that by the end of this class, you will know that very, very important. Yes. Okay, so in this place now, we want to find the derivative. Now we can only find the derivative in this place because there's a little change here. Don't mind the slope I'm drawing here. There's just a little change because this is a curve. This is a curve. And I just find a little tangent line. So I'm finding small slope. So in this place, I use the little change. That's this symbol to be dy dx. And this becomes the differentiation. So this is when differentiation comes in. This is where differentiation comes in. Because of you finding derivative. I'm trying to find derivative. This is where I actually use the differentiation aspect. So that I've already made instances of where you could find this. All of these very, very important. Okay, so I'm just going to take one example and I'm going to explain it using first principle and then we'll fire on from there, so that at the end of today's class you're able to catch up one or two things that could benefit you into understanding differentiation very, very well. I've explained derivative, I've explained differentiation, where it's coming from, what it is, why we are bringing it up. And this is all what you can see in practical problems in physics, in maths, engineering, and so on and so forth. So this is it. It's very clear and it's very widely clear that you can actually use this. Okay. Now, back to the curve. This is we done with the straight line graph. Now I want to deal with the curve graph. Now what happened here is that there's a curve. What can I use? I don't have a little stuff I can curve. There's a little curve like this. You're having a curve in this nature. Very clear, right? Now, I draw my tangent line here Now, if there is a little change, let's say it's an object moves from this point clockwise, there will be infinitesimal change. That's it's moving from y on the vertical axis from y to small change. You've now seen it. Now, how do I find that change? Okay, the object is on the it's on the positive y-axis up, and it moves a little change that you cannot use normal number to say, okay, you move from 1 to 2. When you move from 0.000008 to 0.00, that's infinitesimal change. It's microscopic that you cannot see with your visible eye. Okay, let me now summarize it by saying that the derivative is what you are finding, like what you see. What the differentiation is what you can actually see. You can actually figure out with your memory with some configuration. That's where the differentiation comes in. So now what will happen? How do I find the change? Is where we now have this change plus the small change. I find the change, the negative in the y-axis. How do I find the change in the x-axis? It changes from x plus small change of this. Let me use the black marker so that it won't be clear. So this is what happens here on the y-axis. Y plus the y, that's little change in y, small capital Y. That's what the trading is of del. This is it. You're having this, you're also having this, and so on and so forth. This is also del. So small and big. That's in Greek word. Okay, so that's by the way. So we are having this y plus the y, tells us that it moves a little change in the y-axis from y to little change. That's why we are having this. While on the x-axis, let's say the object has moved from here and it's going to the x-axis. It moves from this to this. Hope it's making sense. Now, if you've not known limit, that's the most reason why you should enroll into the academic. We've done about limits, we've done limits, and a lot of students that have enrolled in our academic have already understood limits, because I'm using those principles of limits to operate, and it will all make sense at the end of the class. Yeah, it will make sense. Okay, now let's deal with a little problem here. Let's just do a little problem, not much. Okay. Let me just wipe this. I believe it's all clear now, very, very clear. Okay. The problem here says, let me read it up. We are given a curve graph as y equal to 3x squared plus 6. Please still note this. Of course, when you look at it, you know that okay, so it's a curve graph, which is really correct. It's not a normal graph that you can just this is a curve graph from what you have seen. So the graph is a curved one. It's a curved graph. It's a curved graph, yes. You want to check here. Here is going to be P, here is going to be Q. And then we are going to have our line here. And then here is y, this is x. And here is our y equal to 3x squared plus 6. So let's solve that problem. Now we are going to apply the first principle. The first principle is quite simple because it's just the change we are using. Like I said earlier, that some textbooks use the capital, that is this symbol. So textbooks use this symbol. So please don't get it confused. Some interchange, but what's important is your basic understanding of what the problem is all about. It's not just what is being used. It's your understanding. That's why I'm trying to break it down. I'm taking my time to lay the foundation so that by the time we start entering deeply into problems, you understand it clearly because you've already gotten a fundamental knowledge of it. Yes. Okay, let me claim this so that we can solve one or two problems before we end the class. And possibly when we do another live class, you understand where we start from. Okay, I said this is a problem you are given from first principle. Now, if you hear first principle in differentiation, what it's all about is just you applying your basic knowledge. Now, I've told you already that the slope for... Just give me a moment. And m is equal to this all over this. So we are given a problem that y is equal to 3x squared plus 6. They say using, let me read the problem very clearly. They say use first principle of differentiation to evaluate it. Use first principle of differentiation to evaluate it. How do I use first principle of differentiation? First principle of differentiation to evaluate this problem. First principle. I'm going to teach you, I'm going to see it, and I'm going to appreciate it. All right, let us dive in. I'm not going to draw the graph, so I'm just going to use the knowledge you've known already, and then we'll fire on from there. It's given as y is equal to 3x squared plus 6. Now, if from the y-axis the curve make a little change, if from the y-axis, this is the y, this is black, this is blue, this is y, and it's a curve graph, of course, it makes a little change like this. I've told you that little change is going to be y is equal to y plus del y. That's, it changes from y to little change again. So how do I find the y? It's by adding them all together. I get my y. I've said that earlier. So the little increment, that little increment is this symbol we use. It's called little increment, little change. That small change the curve makes on the y-axis. What we are going to put here, solving using first principle, using first principle. Okay, that little increment here, we are going to have as y plus del y. Hope it's making sense, which is equal to, now when you see x, you put x plus del x. When you see y, you put y plus del y, and everything becomes simple for you. That's first principle. There is no two ways about you solving first principle apart from what I'm showing you now. So on the other side, we're going to write the constant outside as 3 in bracket x plus del x all squared plus 6. Why? Because the x and y axis are changing. They are variables, so they can change. So because they can change, we know that since it's a curve graph, it can make a little change. So that little increment is making is what we are having here. That's the y. So it changes from this. So if I can add up these two guys, I can get the change in the y. And also, if I can add up these two guys, I can get the change in the x. So that's just it all. Hope you are following clearly. Okay. Let's move on. Now we are going to expand from here. The moment you apply this, the remaining thing is just a little one. It's just your basic knowledge of body mass. Open bracket. I've already finished the work here. Now it's all left for you. What do I have to do here now? I believe you will be guessing, okay, just expand the bracket and then 1 or 2. You are correct. The bracket first. Body mass is a very important concept in your fundamental knowledge in math. So first of all, you open the bracket, you simplify what's inside the bracket. If it's square, that's power 2, power 3. If it's a bigger power, that's when you have to use a binomial expansion in expanding. I believe you've gotten knowledge of it. If you've not, then you go and do some review on binomial expansion. It helps us to expand bigger powers of problems, and it makes what more simpler to us. Okay, let us expand this. We are having y plus change in y is equal to, please note, some textbook do use this change in y here in first principle. They are not wrong, they can use anything, but it's your knowledge of it that matters. Very good. So here we're going to have 3. If we expand this square, we are going to have x squared plus 2 del x plus x del square. We are going to have plus 6 here. You can put this one in bracket if you care, but it's just what it means here. So this one we are going to expand. Even though you use this one, we're going to have this symbol, this plus 2 change in x plus change in x all squared. It's the same thing. It's the same thing, please. Let me up the light so that it will make more sense. So that's what we have. That is what we are having. Okay, so let me just write this. This is where we are. I said, the way I give you the problem, what do I do? They say use first principle. That those variables, that's the x and the y, can change. Possibly they may use y and z, any variable they use. Your knowledge, you know that those are variables because they can change. On your x and the y axis, they can change. That small change is what we are dealing with here. I keep on emphasizing that so that you get what we are doing here. You not get it out. Okay. Now, having reached here, subtracting both sides of the equation by y, what do we have? Now, I want to subtract. You know, in math and physics, there's one funny thing they always like to do. We always like to manipulate some things to get our result. No matter what happens, we want to fight until we cross the particular barrier. By all means, we are fighting, we are targeting something. So we do everything we can to hit up our target. Okay. Okay, so if we want to subtract from the equation, we are going to have y plus change in this plus y is equal to 3. Like I'm multiplying it, we have 3x squared plus 6 change in x plus 3x change in x squared plus 6. Okay, plus 6. All right. I think minus y is also here. Okay. All right. So that's what we are having. So what do we do from here? Yes, I just give you like 2 to 7 seconds to think of what we are going to do here. Yes, I believe you must have been thinking, what do I do, or what can I do from this place? Okay. Now, what we did here was that we subtracted the original equation. Like for now, from you can say subtract equation this from this. That's, you can say this is equation 1, this equation 2. That's the original equation from what you have got here, and you are done. That's, you are subtracting the original equation from the solution you've gotten. This equation from this, and you get an answer. So if you do that, you are going to have this minus y. Let me clean the first one. So we are going to have y plus change in y minus y. Remember the equation is y. They say find this. Is in first. Well, let me check the equation again so that we're able to answer it carefully. 3x squared plus 6. Okay. So we're going to have this is equal to 3x squared plus 6x plus 3x change in square plus 6. Now I'll minus this from the original equation. If you minus that from the original equation, we are going to have minus 3x squared plus 6. Remember that this minus affects everything that's inside the bracket. So if that should affect everything inside the bracket, we are going to get a result. And what's that result? Now, here becomes minus. So this cancels this guy. 6 cancels this. Y cancels this Y. So what do we have left? We are going to have the Y as equal to 6 dot x plus 3 x squared. Yes, this is what we are going to do. So from here, we say divide both sides. I'm taking my time because when I start giving the third and the fourth example, I'll just be hoping that you understand it. Divide both sides by changing x. Divide both sides by changing x. So what do we get if we do this? We have changing y all over changing x as equal to 6x plus 3 changing x squared all over changing x. Of course, this one will cancel this. Yes, that will cancel this, and we are going to, this will cancel this. So we are going to have, let me clean the upside, please. We are going to have changing y all over changing x as equal to 6 plus 3 x change done. Okay, now that these are our answer, but we are not going to stop here. Now, assuming, because there's going to be a change. Why? Those are variables, they are changing. If that x tends to go down, this is my curve graph. If let's say this curve goes down, of course it will be approaching the zero aspect of the x, right? Yes. If it goes on the torsion zero, then that means that that curve is approaching zero. If it goes there, it's at 0. Now assuming limit as x tends to 0, what do we have? We are going to have, when x approaches 0, we are going to have changing y, changing s as equal to 6, because here becomes 0. So here becomes our final answer. I'll give you some time to process it. This is 6. Forgive the marker. So process that answer so that we take one more before we go. So what we've just done now is the first principle. Please note it, what we have just done now is nothing but the first principle we've just done now. So it's the first principle we've just done. Okay. So when we come back next time, we talk about the next example and move on from there.